Okay, so question 4. Sample of titanium was ionised by electron impact in a time of flight spectrometer. Information from the mass spectrum about the isotopes of titanium is shown in Table 1. Calculate the relative atomic mass of titanium in this sample. Give your answer to 1 decimal place. Now, this is often forgotten, and what I would suggest you do, as soon as you read that, give yourself a little reminder down here that you need to write your answer to 1 decimal place. And then from here, we're working at the relative atomic mass. Remember, it's just a formula, really, of the mz value multiplied by its abundance. So there's your formula there, divided by the total abundance, and because this is percentages, that's going to be 100. If you work that out on your calculator, you will get 47.825. So to 1 decimal place, so there's my 1 decimal place here. Looking at this 2 there, means I need to leave it at 47.8. So my final answer here is 47.8. 1 mark for the working, 1 mark for the correct answer. Okay. Part B. Write an equation including state symbols to show how an atom of titanium is ionised by electron impact. So that's the one where you bombard it with an electron and it knocks an electron out. Give the mz value of the ion that would reach the detector first. Okay, so let's start with the equation. So titanium, finding that element on the periodic table is going to be Ti. Remember, these are all in the gaseous state. And you can either do this, so plus an electron, which gives titanium plus, because we've lost another electron, or lost 1 electron from there, plus 2e minus. And of course, the electron there can cancel out that. So you could leave it like that. That would be okay. Or if you wanted, you could have plus 1 electron in front of the arrow and plus 2 electrons after the arrow. You have to have state symbols on here. Without those, you would not get that mark. The mz value of the one that would reach the detector first. So remember, the one with the lightest mass or the lowest mass is the one that's going to move at the fastest speed. So that's going to be 46. So it's asking for the mz value, so of the ion, so 46, or some of you may have put 46 Ti plus. Okay. And then part C, calculate the mass in kilograms of 1 atom of 49 titanium. There's the Avogadro's constant. So the mass, remember, of 1 atom is equal to, now we've got 49 grams, so it needs to be in kilograms. So I need to divide that by 1,000, which is the same as times 10 to the minus 3. Now that is the mass of 6.022 times 10 to the 23 atoms, because that's what a mole is. So it's 49 grams for every mole of those. So if I divide it by that, I will get the mass of 1 atom, which is 8.14 times 10 to the minus 26. So that answer goes down here, 8.14 times 10 to the minus 26. And then part D, time of flight mass spectrometer has an ion is shown by the equation. In this equation, D is the length of the flight tube, M is the mass in kilograms of an ion, and kinetic energy or Ke is the kinetic energy of the ions. In this spectrometer, the kinetic energy of an ion in the flight tube, so this is the kinetic energy. The time of flight of 49 is this, and we are asked to calculate the time of flight of the 47. So very simple formula that we can use here. So because I'm comparing two ions in a mass spectrometer, they both have the same kinetic energy, which means the formula I can use is m1 over T1 squared equals m2 over T2 squared. And with the masses, I don't need to divide by 1,000 or divide by Avogadro's number, because if I do it on the left, I have to do it on the right, which means it all just cancels out. So all I need to do is put my values in. So the mass of the first one is 49, and the time it takes is 9.816 times 10 to the minus 7 squared, which equals 47 divided by T2 squared. So if I multiply both sides by T2 squared, I get T2 squared times 49 over 9.816 times 10 to the minus 7 squared equals 47. And then if I divide both sides by 49 and times both sides by 9.816 times 10 to the minus 7 squared, I get T2 squared equals 47. So divide both sides by 49 times both sides by 9.816 times 10 to the minus 7. Of course, on the left, that means that they will cancel out. If I work that out, I get 9.24 times 10 to the minus 13. Very often people forget to do the square root now of T2 squared. So T2 square root of that is equal to 9.614 times 10 to the minus 7. Now, one thing I missed out, which I mentioned earlier, is appropriate number of significant figures. So we've got to go back into the question and have a look at the number of significant figures that we're given. And the significant figures that I am given, if we just change colour, so there's 4 significant figures here, 4 significant figures here, which means the answer here has to be to 4 significant figures as well. So where are the marks? Well, there's 1 mark for putting the numbers into the equation here. There's 1 mark for working this out, and there's 1 mark for getting the answer. So the risky thing to do here is to plug it all in your calculator and hope that you get the right answer, because if you make a mistake, you lose all of the marks, whereas at least if you've shown you're working out, you will get at least some of the marks.